Matthijs, and thank you for accepting to do this interview. And I'm sure my audience, specifically my students, are very excited to hear about you and your experience. And let's start by asking you somewhat personal question that how did your data science journey began? And where did you start? How did you get where you are now? And what were the barriers, if there were any?
Yeah, so I'm a computer scientist by training. I did my integrated master's in computer science in Utrecht. And after that, I first didn't know what to do, but I always liked to do research. And then I got the opportunity to do a PhD in data mining, also in Utrecht. And that's really where it started. So we really started from algorithms, trying to find patterns. I think we will talk a little bit more about that also. Yeah, I liked it so much that after that I continued to do a postdoc. And also I got a Dutch grant, which allowed me to go abroad. So I was a postdoctoral researcher in Leuven in Belgium for 4 years. And then in the end, I got back to the Netherlands. I got a position in Leiden first as a senior researcher, but then I became there a tenure track assistant professor. And as of this year, I'm now associate professor and I'm leading my own group there on explanatory data analysis.
When you're saying it, it sounds very easy, but how easy was it in reality?
Yeah, it's definitely not always so easy. Yeah, so these days there's a lot of attention for data science and AI. So also that means that there's a lot of positions in all levels, like PhD students to full professors. But when I was a postdoc, which was for quite a long time, it was very hard to find a position either as a tenure track assistant professor or any professorship position, because there were very few positions especially in the Netherlands, where I wanted to get one. So that was quite tough, and that also made that I was a postdoc for quite a long time. But the good thing is that although this gave quite some uncertainty, and this is hard, but it also gave me the opportunity to really develop my own research line and to profile myself as an independent researcher without having all the management and teaching tasks that come with being assistant professor, which is also fun, but it is a different focus.
Yeah.
And this brings me to then the tenure track, which is, I think, a pretty tough system on people because it asks a lot. It has high expectations on research, on getting grants, funding, on research and management also. So that's also quite demanding. And in hindsight, it maybe seems that it was quite easy if you look at my CV, but it wasn't always like that. Especially the grant writing was quite new for me as an assistant professor. And yeah, with the very low acceptance rates, it can be quite frustrating when you spend months on writing a proposal and you really believe in it, and then it gets rejected. And it takes also some courage to pick up again and continue.
Yeah, that's true. I have been talking to people from industry and academia in this interview series. What do you think does it take to build a career in data science, specifically in academia?
I think, well, different things, but one of the most important thing, and this links back to my previous answer, is persistence. So if you really want it and persist, then in the end, you can manage, but you need to try multiple times. You have, especially, for example, with grants, you need to just keep trying, even if there is rejection. Try not to take it personal, although this can obviously be hard, but persistence really helps. Then, of course, you need some good ideas, because this is what research is also about. And to be able to persist and keep doing it, I think what is really important, that you really should find something that you enjoy, because as long as you enjoy it, then I think it's worth keeping doing it.
Yeah, that's true. So talking about ideas, let's get about more to the topic of what you're working on. In your personal websites and in your PhD thesis title, you say patterns that matter. What does it mean, really? I mean, are there some patterns? I mean, what patterns, first of all, we're talking about? And what are they that matter, and what are the not that much mattering one?
Yeah, so in general, I think data mining is now a couple of decades old, and for a very long time, the people that have developed data mining algorithms. It was new, so it was very understandable, but they focused very much on finding patterns and making this computationally feasible. But I think now in the past decade, we've slowly come to the realization that it's easy to find, discover, mine many patterns, but that doesn't mean that they're all interesting, that they're all relevant. And over the past decade, there has been much more attention to finding patterns that can make a difference, that really provide information, knowledge. And this is harder than just mining all patterns that you could possibly find, but you really want those that are meaningful in some way. And of course, this depends very much on what problem you're considering. And there, I think it's very valuable that over the past decade, we've seen that uh, data mining has moved slowly towards also more real world applications and case studies, and not just the benchmark data sets that were often used before that. So, yeah, so more towards data science in a broad sense, where many interdisciplinary collaborations are going on, and you have real world problems that need to be solved. And then you really find out also what problems, limitations your methods still have, and what is needed to solve that.
Now, how do you target these patterns? Are you going to dig out all the possible patterns and then sift through them, or you're going targeted from the beginning?
Yeah, there are different ways that this can be done. So it depends on the problem, which one is feasible. Ideally, of course, you would only target at those patterns that you want in the end. But sometimes it's just easier and even faster to try to mine everything first and then sift through them afterwards with some other selection criteria. That's a very algorithmic question that very much depends on the context. But I think the most important thing is to try to formalize in a principled way what are the patterns that you would like to have in the end. I think that's one of the key questions. When you talk to some person from some other domain in healthcare or well, wherever, they often have some data and they have some idea of what could be in it, but then to try to formalize that I think is one of the nicest challenges of being a computer scientist in data science, is that you really can try to formalize the problem, make it as specific as possible, and then try to solve it with some algorithm.
And what you said brings me to the next question about asking the right question. It seems it's very important to ask the right question. But is there any single recipe to defining the right question? How do you even know that you're on the right track with your question?
Yeah, I think that truth is we don't always know if we're on the right track. It's research, and sometimes things don't work that you expect or hope to work in advance, and that's reality. But of course, there are things that we can do, and I think one of the most essential things that we should always do is to always try to understand as much as possible the problem and the data at hand. And if you don't understand the problem yet completely or the data, then do the steps that help you bring closer to that goal. Because only if you really understand what's going inside an algorithm or what's going inside some data, if you understand that, then you can also improve on that and see what are the limitations and shortcomings.
Interesting. So what you're saying is also that asking the right questions depends very much on understanding the data. So getting to the data part, what do we need to have as a data? How much the quality of data matters, or even the quantity? Could I still get meaningful information out of not that big of a data set? Because this is, especially in certain fields, is a problem that we don't have that much data, but we still want to get something out of it. So is there any way out of that, and how much the quality of the data matters?
Yeah, I think it depends on the problem. So for some problems, you probably need a lot of data, especially if you want to be really sure. But in general, I think there's also things that can be done with not that big data. And that's where it's really nice that we have so many different methods these days, right? So if you want to do maybe deep learning, then yes, you probably need a very large data set for training. But if you do other types of learning, then it might be that you can also learn from relatively small data sets. So for example, what we do is we use often what is called the minimum description length principle for model selection. So that's a way of compression, so that we say that we want to find that model that compresses the data best, because then it captures the structure best. And this has the nice property that you automatically balance the complexity of the model with also the size of the data. So if you have less data, this means that you have less evidence. So then you should be less sure about your conclusions and also be less specific maybe. So then you should find a different type of result. And so that means that if you would add more data, then maybe you would get a different result that is more specific, but still you can learn something that is more generic if you have a smaller data set.
Interesting. You talk about having this certainty. The more data we have, we are more certain about the outcome of our project in a sense. But it is not only about the data, is it? Because sometimes we don't put trust in the models that we are working with as well. So it is difficult to draw a line and say that after this amount of data, I am 100% sure, 90% sure about the outcome. And I was going through your projects and I saw one of the goals that you have is interpretation of data science project outcome. Somehow you explain the whole thing. How close we are there to interpret what we are getting an outcome and build a trust in what we are proposing, basically.
Yeah, I think we data scientists or data miners, I think we say that we can interpret our outcomes, the patterns that we find. And I think we can to a certain extent, but then the trust issue, I think, is something completely different, because if you really want to implement your results, so deploy your algorithm in a production environment, this is really tough. So I'm currently also collaborating with some people at the intensive care unit of the Leiden University Medical Center. And there we're looking at the deploying methods that can predict whether a patient would be readmitted to the intensive care if they would be sent away now. So because then they would probably come back worse than they are now, and then you would maybe want to keep them at the intensive care as they are now. And that decision is now made by medical doctors. And there are now algorithms that also can do that. But the question is, do these doctors trust these algorithms? And how would they use it? How should they best use them? Because, of course, the responsibility always remains with the doctor. So how can you convince these doctors to use that and to give that also some trust? And what is needed for that? And these are very hard questions, I think, and also questions that there is no generic answer to this, but that's something that we have to, well, at least for now, work out case by case.
Okay, good. At the beginning, we discussed about the pattern that matters, and I think you're talking about in a scientific sense, but is there any social element to that these matters because they have some social impact on the society? Or how much do you think this should be an element when we are doing research?
Yeah, so I started doing data mining really from an algorithmic perspective when I started doing my PhD. But over the years, one of the aspects I've come really to enjoy about data mining or data science is that you can do both fundamental research on one hand, looking at math and doing algorithms and so on, implementing. But on the other hand, you can also show that what you do actually makes a difference in practice, or at least it could be used in practice. And there I focus on two application domains in a very broad sense. So one is healthcare. I already mentioned intensive care.
Yeah.
And the other one is industry. So for example, we worked on a new algorithm for anomaly detection in data that is collected from steel coils for BMW, so the car producer. And they're actually using that algorithm now in practice in their manufacturing factory. So that's pretty cool. Of course, our industry maybe is not really a societal goal, but still they have also an interest in getting good results. And that's the same, I think, in healthcare. People working in healthcare really also have a best interest in helping their patients. and also for many people like me and also people in my group, trying to improve what can be done in healthcare is I think can make a difference, and it's very motivating also.
Interesting. You're talking about data science in several different fields, in healthcare, in industry, I think tax report, and many other things. It seems that it's not enough to have expertise on one single domain. And data science is some sort of expertise that it is needed in all sorts of domains. Do you think we are moving toward the phase that our educational system needs to change to accommodate for this new data science needs somewhat?
Yeah, so first of all, let me be clear that I'm definitely not an expert in all of those fields.
Yeah, but you have some basic ideas. This is exactly the question. Do the people in the other fields need to have some basic ideas about the data science?
Yeah, so in that sense, I agree with you that it's not possible for one person like me to be an expert in all those domains, but many of the PhD students, but also the master students that do the actual research, they are usually now or often now doing interdisciplinary research and should be experts in two fields, right? So they should know something about AI and data science, and they should know something about like law or the other examples we've been mentioning. And you're right that well, I don't think this will completely change the education system, but I do think that what will change and is already changing is that AI and data science as topics will be included in more and more programs for bachelor and master students in the upcoming years. And this will change a lot how people trained in different areas can deal with data. And this is actually something that we already seeing happening in Leiden right now, where on a university scale, there will be AI courses for all programs, basically.
That's really cool. Getting to the educational system, probably this is where we could close the discussion somewhat by asking you if you have any final word of wisdom or any recommendation or anything in that line for the students who are listening to you and who wants to build a career in data science, but not only, they are from the other fields as well, but they want to have data science as an element to whatever they are doing.
Yeah, so I think there's two things I would like to mention. And the first is that I think these days there are many opportunities in artificial intelligence and data science and related fields. So as a student, you are in a great position because you have a lot of choices of things that you could do in your future career. And in academia, in government, in industry. So my recommendation would be to explore and really try to find out what you really enjoy and take that into account when making choices, because you will be able to find opportunities. It's really up to you to decide what you like to do and what you want to do in the future. And of course, you can also at some point still change your career. So that also makes it easier maybe. The other thing is if you choose a thesis project or also a PhD project, then I think it's important that you do not only consider the content, the topic, but also the supervisor and the lab where you would be working. Especially if you do a PhD, this is 4 years, this is a very long time. So the choice of your supervisor has a huge impact on how you experience research. And I think it's very important to take that into account as well.
Thank you very much. It was a very interesting and insightful discussion that we had, and I am sure that the people who are listening to us have enjoyed it a lot as well. And thank you very much for being with me.